Hello everyone. Today we learn an easy way to know visual field defects according to the optic, chiasm and direction of the blindness. As we know that the normal pathway of the vision, it's composed of optic nerve, then we become optic chiasm, then we become optic tract, then optic radiation, and then reach to the primary visual cortex. Like that's the eyeball, then optic nerve, optic chiasm, then optic tract, then optic radiation, then the primary visual. So any breakage in these components, there will be blind. That's all the visual defect types. So to know the different the cause of the visual pathway, we make an arrow by the vision loss. In the first part there's complete loss of the one eye, so it's completely loss of one eye. Regarding second part, as we see that the outer parts of the eyeball, there's visual loss, so we make this like this, and in below it we see that same direction. All same direction. Okay, now I explain. As we see in bitemporal hemianopia, it's different directions. So if you mix these two arrows, will be like this. So this shape, it's like the chiasm, optic chiasm. So the cause will be optic chiasm, the defect in optic chiasm level. As we see, all different, all the visual field parts behind it is same direction. So if it is all the same direction, it's after the optic chiasm. The lesion is after the optic chiasm. To differentiate between the different types of the lesions, because as we see, we have the optic tract after optic chiasm, and we have the optic radiation and visual field. To differentiate between them, as we know, the optic tract is composed of the two fibers, so it will be full of the part. And if we separate these two fibers, so it's giving the quarter will be quarter defect. So to differentiate between these two fiber defects, as we see that the fiber that's outside, and it is temporal fiber defect, because it's outside, so it's called the superior quadrant defect. And the under fiber, it's inferior parts, so it's in the lower parts, so it will cause lower cortex, lower quadrant defect. Regarding the posterior lobes, posterior occipital lobes, it will be defect in the middle. As we say that all this will have same direction, because it's posterior to optic chiasm. So if anterior to optic chiasm, will be complete blindness. If it is opposite direction, it will be optic chiasm the cause. As like optic chiasm, it will be opposite direction. Below optic chiasm will be same direction. And regarding the differentiation in different types of the optic radiation, we depend on the location of the fiber. If it's superior, cause the superior. If it's inferior, it's cause inferior type. And that's another. Now let's make some exercise on this image to know the type. As we know, we see that in the first one is the complete blindness of one eye, so it is before optic chiasm, it's one eye. And in second image, as we see, it is direction is opposite to each other, so it's at the level of the optic chiasm. And third one, direction is opposite to each other, so it's same at the level of the optic chiasm. And fourth one, as we see that the direction of both eye will to same, so it's at the level of the after optic chiasm, and it's because it's fully taken half of the eye, so it's optic track. And to the five, same direction, so to it's after optic chiasm, and because it's half of it, so it's optic radiation. It's because it's upper part, so the outer fiber. Regarding sixth image, it's same direction, so after optic chiasm, and because it's the half, it's optic radiation, and it's because inferior, so the inner fibers. And 7-1, because same direction is after optic chiasm, because it's full and taken middle of it, so it is from the occipital. And I hope you get benefit from it and learn all of it.